second try. Try a different approach. So I was trying to make a point that if you just use dz, dy, dx, it becomes like next to impossible. It's not on. You do have an interval that's possible, but it just takes many pages. It's very hard. So what is this other approach to getting this volume, the mass of this object when the density is z? Well, instead of using dv equals to dz, dy, dx like before, you remember when we had dA equals to dy dx, but also we wrote this as r dr d theta, right? What is that for? R dr d theta? Polar coordinate system, right? So what you do is you leave the z as z, but you change dy dx as polar coordinates. Okay? Then the calculation becomes a lot easier. So let's see. So you're going to rewrite dv. So instead of this, you're going to rewrite dv as r dz dr d theta. So that when you do the interval, mass is sum of its parts, which is rho times dv, which is z. Z is z, doesn't change. But then now you have r dz dr d theta. Z goes from, well, there's the first challenge, okay? Now we're using r theta instead of x and y. So how do we switch this into something that uses r and theta? Let's write down the formula for that. R is square root of x squared plus y squared. Theta is tangent inverse of y over x plus some alpha, where alpha is this multiplication if you're on the left side, actually plus pi, negative pi. But then there was also x equals to r cosine theta, y r sine theta, right? So there are two ways to go about this. One is to quickly see that, oh, if you square both sides, r squared is x squared plus y squared, so this just becomes 1 minus r squared. If you can see that, that's wonderful. Okay. If you can't see that, then what you can do is you can just replace x by r cosine theta, y by r sine theta. That always changes x into r and theta. So that makes that equation as 1 minus r cosine theta squared minus r sine theta squared. And that's equal to 1 minus r squared cosine squared theta minus r squared sine squared theta. And then if you factor the r squared out, you get cosine squared plus sine squared. What's that? 1, right? So you do get the same thing. Yeah. So either way, you should be able to change this into that equation, because now that if you're going up to fill the space, you start from 0 and where do you end? 0 to where?
1 minus.
1 minus r squared. That's what z is, right? You have to use this one. And then once you flatten it out on the xy plane, you get the unit circle as before.
I have a question.
Yeah.
For the z equals 1 minus r cos.
Yeah.
How do you factor the 1 out when it just goes to 0?
No, this is just 1, right? So it's
No.
1.
You have 1 minus r squared cos squared theta minus r squared sine.
If I factor the negative r squared out, then these two become positive, right?
Yeah, but how do you get the 1 out? That's first.
No, this is
wait.
1 as a separate thing. These two are just, you have 3 terms, okay? It's not like 1 minus r squared times cosine squared. It's 1 and then this guy and then this guy. You have 3 terms. And from these two, I'm factoring the negative r squared out. So this is plus. Okay? All right. So you get this. And if you have dr d theta, that means you're increasing the radial direction. So you're painting this region like that, right? Radially outside. Now, where does your r start and where does it end?
Start at 0.
0 until
1.
1, because that's the radius of this circle that we found out that before, right? So this is from 0 to 1. And then theta is from where to where?
Negative.
It's a full circle, right?
0 to 5.
To 5. Okay. Now let's see if this is any better. This is going to be 1/2 z squared r. We plug in 1 minus r squared and 0. And then 0 to 1, 0 to 2 pi dr d theta. Okay, so what happened is I integrated this function with respect to z. Since r is just a constant multiple, only z gets integrated, so you get 1/2 z squared r. You see that? And then to that, I'm plugging in these two. So that's going to give me, let's pull the 1/2 outside. That's going to give me this squared, so it'll be 1 minus 2r squared plus r to the 4th times r dr d theta. Okay. And then that's going to be r minus 2r cubed plus r to the 5th dr d theta, whose integral is now 1/2 r squared minus 2/4 r to the 4th plus 1/6 of r to the 6th. And then you're plugging in 1 and 0. Okay, so my previous answer was definitely wrong. If you plug in 1, these two just cancel out and you get 1/6. Okay? So you have 1/2 integral from 0 to 2 pi of 1/6 d theta. And that's just 1/12 theta. 2 times 6 is 12, right? Theta, and you plug in 2 pi and 0. So you get pi over 6. Okay. Really? Okay. So I wonder where the mistake was.